To get started with this lecture, I want to discuss the usage of macros in the Unreal Engine. Gameplay classes in Unreal uses standard C++ syntax in conjunction with specialized macros to simplify the process of declaring classes, variables, and functions. Now, based on what we've discussed so far in creating C++ classes, you might be thinking it does not exactly look simplified since we have all of those macros, but actually it reduces the amount of code that we would have to write otherwise to expose our classes, variables, and functions to blueprints, for example. In upcoming lectures, we will discuss certain macros with certain specifiers that will allow us to make our variables visible or editable in details panels, and which will also allow us to create getter and setter nodes within the blueprint editor, for example. And the same thing with our member functions. We can use those in blueprints by specifying certain macros with certain specifiers. We will use these special macros that we will discuss in this section and in upcoming sections to mark declarations to participate in the reflection system in Unreal Engine, where essentially Unreal Engine is made aware of the classes, functions, and variables that we decorate or mark with those macros. Okay, so with that idea in mind, we will continue on here. Macros in Unreal Engine typically generate code that enables editor integration. Now, while this is really handy, I would like to mention here that it can give us some weird behavior in the IDE, so in Visual Studio with IntelliSense, for example, code completion issues. That can be an issue for some people if you are relying heavily on code completion. So you do the dot or the arrow operator and you expect a list to pop up and to show you what members you have access to, for example, or you expect IntelliSense to sort of guide you and help you to show you where there might be errors in your code. Well, because of all of these macros and because Unreal Engine is so huge, you may have to wait quite a bit for IntelliSense to catch up. Also, with something called live coding, where we can basically compile from within the Unreal editor, our code does not always reflect, so we have to close the editor down and then build from the IDE again, but I will demonstrate that to you in upcoming subsections. So many of those errors can be hard to track down and fix. You might think that you have a bunch of errors, but really those are mostly false positive errors. This is why you should focus really on what's going on in the output window and not on the error window that is in Visual Studio, and also what we get from the Unreal editor logs as opposed to what we get in the error window within Visual Studio, for example. One example that we've seen already at this point is the uClass macro, which is going to decorate our classes, as we've seen in the previous example with the uObject and the aActor. Again, those macros mark those classes to participate in the reflection system. So what I'd like to discuss in a bit more detail now is what is actually meant by reflection. Well, reflection is the ability of a program to introspect or examine itself at runtime. Reflection is not native to the C++ language, so Unreal has its own custom system. In Unreal Engine, reflection is used for detail panels, serialization, garbage collection, which we will discuss in a bit more detail in an upcoming subsection. Also for things such as network replication and blueprint C++ communication. As I mentioned, we have special macros that we can supply with special specifiers or arguments, which will allow our variables to essentially show up in the editor, such as in our blueprint classes, in the details panels. This allows the artist to set default values, even though that class was defined and that variable was defined in C++, and that blueprint simply derives from that C++ class. But as I mentioned, I will discuss this and actually show you some examples in upcoming subsections. Now, reflection is opt-in, so we need to specify the classes, properties, and functions that we want to participate in this reflection system, again using predefined macros. Something called the Unreal Header Tool, or UHT, will harvest, or in other words collect, information from our classes from these special macros and will generate additional code for the class, and that will actually be located in an appropriately named .generated file. So what is this Unreal Header Tool that I mentioned, or UHT? It is a custom parsing and code generation tool that supports the uObject system, that is the Unreal Classes system. Now with Unreal, code compilation is going to happen in two phases. In the pre-processing step, the UHT, the Unreal Header Tool, is invoked, which parses the C++ headers. In other words, it searches the headers for Unreal-related class metadata, so the macros basically, and the arguments or specifiers that are provided in those, and it's going to generate custom code to implement various uObject-related features. So again, this happens in the pre-processing step. Then the normal C++ compiler is invoked to compile the results. As I mentioned previously, the Unreal Header Tool, or UHT, is going to harvest or collect information from our classes, from the special macros and specifiers that we provide, and it's going to generate additional code for the class. Now where will that code be located? Well, it's going to be located in the .generated.h file. That is the specific class name such as my dummy actor or something like that, .generated.h. Okay, so the code generated by macros such as uClass, for example, will be located in that header, in that file, and it marks the header as containing reflected types, and without the include, the compilation will fail. The .generated.h include must also be the last include in the header, otherwise you'll also get an error. This slide includes some examples on those macros. We have seen the uClass before. We also have the uProperty and the uFunction. So our declarations are prepared by appropriate macros, or in other words, decorated or marked with these appropriate macros. uStruct with a struct, uClass with a uObject, for example, and whatever derives from uObject. A member variable will be decorated with uProperty and a member function with uFunction. And as I mentioned, the Unreal Header tool will harvest or collect this information and generate additional code from that. Here's a quick example of decorating members, so a member variable and a member function. The member variable, in this case a float, we will decorate with the uProperty, and then the member function with the uFunction. An easy way to remember this is to think of it as an Unreal property or an Unreal function. Now we will discuss some of the specifiers or the arguments that we can pass to these macros in upcoming lectures. In the C++ experiments project, in the header file here for dummy actor, notice that we have this include dummyActor.generated.h, and the same thing if we go to dummy object here, for example, we have dummyObject.generated.h. So of course that is the generated file. We can right click on that and then we can go to that document, which will open that up. Notice that at the top here we get this is generated code exported from the Unreal Header tool, and we should not modify this manually, right? So we're not really concerned with what is going on in here. Notice that that is the final include here. At the top of that we have core minimal.h. I can also right click on that and go to that document. This is going to contain types from Unreal Engine's core programming environment, such as arrays, stuff for mathematics, and so forth. So T-array, for example, you can see that we have low-level includes here, forward declarations, commonly used headers, and so forth. That is so that you don't have to do an include for everything that you want to do in Unreal Engine, such as using f-vectors, T-array, and so forth. You will become familiar with those types as we work through the rest of the course. But for example, Unreal Engine has its own way of doing arrays, so it has something called a T-array. We will discuss those as we go along, but the point is, those are included. We don't have to go and include a special header or anything to use that, because those are commonly used headers. Alright, next we have this include here, which is the actor, actor.h. Of course, we are deriving from actor here. So if you go over to the dummy object.h here, for example, that will also have that core minimal, and then we have this uObject thing here, this include, because we are deriving from uObject. In the body, we also have this macro right here. The generated body macro will essentially inject additional identifiers into the class body, so functions and type definitions, and it is required for the object system to work properly and for reflection and everything to work properly. I've also discussed this macro right here, so your project underscore API, in this case CPP experiments underscore API. So to end this lecture off, I will do a bit of a summary and a bit of an explanation on what that actually means, and I will also discuss some of the files in a bit more detail throughout that explanation. Some of the files that you get, so under source, for example, CPP experiments, notice that we have a few extra files such as the pull.cs file, for example. And so hopefully by the end of the lecture you'll have a better understanding of all of these macros, and that is really boilerplate stuff. You will get used to having these around in your classes and using them as we move forward for your properties and for your functions. I do understand that it can be a bit frustrating when you get into Unreal Engine and you want to get started quickly, but of course as C++ programmers there's always something new to learn, and whenever we start using a new framework we have to become familiar with the ins and outs of that and become familiar with the basics of that. Okay, so wrap up the lecture discussing this macro right here, and in the upcoming lectures we will discuss a few other things such as the programming conventions, and then also moving forward, as I mentioned, we will discuss the macros right here, uProperty and uFunction in a bit more detail, along with the specifiers that we can pass in for those. That project name underscore API macro is basically an organizational tool. it defines the code set, or in other words a module to which the class belongs. And this is necessary if you want to expose the class to other modules, and that is useful for modules or plugins that expose classes to provide functionality across multiple projects. To demonstrate the idea of modules and having your project separated into different modules, I've created an unrelated project called Demo Project based on the top-down template, a C++ project. So the name of this project is Demo Project, but I've actually created a module called Module Demo. I already have this module set up. You don't have to set this up by yourself. This is just a demonstration. But for example, in the Solution Explorer here in Visual Studio, I'll just go ahead and float that so we can see the outline of that. I don't want to move my panels around just a bit because I'm having to set it up in a certain way here for the recordings. So I'll just float this, and notice that we have the engine project and we have the game project here, Demo Project, and we also have the different modules. So we have the Demo Project, and then we have the Module Demo. Both of those folders, the Demo Project and the Module Demo, are nested within the source for our Demo Project. Our Demo Project has a builder.cs file for that particular module, for the Demo Project module, and then for our Module Demo, that also has a build.cs, so that will be moduledemo.build.cs. Again, the goal with these files is to make it visible to the Unreal Build tool, because the Unreal Build tool is going to look at the build.cs files for dependencies instead of looking at the solution file. In the constructor, we have this private dependency module names .add_range. In that, we have core UObject, and engine. Those are modules that are dependencies for your module, and that makes several classes available to this particular module. The demo project will have different modules, including our module. This module demo, for example, will be specified as a module. That will be one of the dependencies for your demo project module. In the module demo module.cpp, this is going to implement the particular module using the implement_module macro. It needs to be implemented in this way, and through this it's made available to the C++ code. In the demo project.eu project, if we go ahead and open that up in a text editor, or I'll just open that up here in Visual Studio, you will notice that the modules list shows up. First we have the demo project module, and that is followed in braces as well with our demo module. To use code from our module in our project, we need to register that with our .eu project file, and we also need to set that as a dependency for the game's primary module. That is in the build.cs file for your game's primary module. You can see we are registering two modules here. We are registering the demo project and also our module demo. I'm not going to go into too much detail on the different settings that you have, because this is just a high-level example. But for example, with the type, we can specify runtime, which means that we can use that module when the project is running as a standalone application or in the editor. So when you have the Unreal editor open, we can also create editor type modules which can only run in the editor, just as an example of some of the changes that you can make, depending on what you want to do with that particular module. Finally, in the demo project.build.cs file, where we have the dependencies, you can see we have a bunch of dependencies here that are also different from some of the other projects that you may have. For example, we have core UObject, engine, input core, head-mounted display, navigation system, AI module, and Niagara. The final module or dependency that we specify here is the module demo, which is our custom module. This is definitely not a demonstration on how to set this up. This is just a high-level overview. I may do a more detailed explanation in a future module on how to set this up if you need to do that. That is not necessary for your first couple of projects. Again, this is just to demonstrate why you have some of those macros. With that module configured, I will create two C++ classes in this next subsection, one for each module, for demo project and for the module demo. So I'll create a class here, C++ class named myActor. Notice that in the dropdown next to the name field, we can now choose the target module for our new class. I will select demo project as the target module for this new class, myActor. You can also separate the classes out in public and private folders if you want. And I will click create class. I will create another C++ class, an actor. Click next. I will name this next actor module demo actor, and I will select the target module. as the module demo for this new class. Click Create Class again, and it will open up Visual Studio. Back in Visual Studio with our actors created, in the module demo actor.h, notice that a module demo actor belongs to module demo underscore API. If I navigate to the myActor.h here, notice that myActor is part of demo project underscore API. Notice again the difference here between these. Module demo actor is part of the module or custom module, whereas myActor is part of the demo project module. And now in the Solution Explorer, again, if we go ahead and inspect that, notice that in the demo project, we have these folders set up. We have the demo project and the module demo. And as I mentioned, you can separate out the headers and the source files in the public and private folders. So this is the sort of setup that you may see. Again, just a basic high-level example on this.